Here we have two equations and two unknown. I'm going to multiply equation number 1 by 4. If I multiply equation number 1 by 4, because I see the coefficient of y here is 1, coefficient of y for the second one is -4. So it looks like if I multiply the top row by 4, I can eliminate these two. When I multiply the top row here by 4, it looks like everything cancels. So what that means? When everything cancels, what kind of line we're looking at? Are these two the same line? It looks like they're the same line, are they? Because if I multiply the top row here by -1, don't we get the exact same equation? If we have exact same equation, they must be the same line. So these two equations, although they don't look like the same, but they're the same line, same exact line, because if I multiply the top row here by -4, I get exactly the same numbers here. So it means they are dependent, right? Remember those lines that we talked about? The dependent is exactly the same line. The lines are right on top of each other. So the equations are called dependent. So that means we have infinitely many solutions. All those points of intersection on the line are one solution. So infinitely many solutions here. And this is how you write that. The solution set is the set of all points on the line with equation 2x plus y is equal to 6. This is a fancy way to write this, saying that all the points on the line are the solution. So this is for a special type of system of equation where you get infinitely many solutions. So it means they're dependent. Now let's take a look at this example here. If I multiply the first equation by -2, because that makes sense, because this is 4, right? And this is 8. If I multiply the top row by -2 to make these two opposites of each other, then I would get -8, which is opposite of 8 now. That's good. But look what happens here. The y cancels too. But this time, the constant doesn't add up to 0. The constant adds up to a different number. So when that happens, what kind of line you're looking at? What kind of line that you have? Obviously, they're not the same line because the constants here are not the same. So it means those two lines are what? Parallel, yeah. So the result of adding the equations is false. So what that means, which indicates that the system is inconsistent. The only time the system is inconsistent when there's no solution for it. Otherwise, it would be consistent. If you have infinitely many solutions, or at least one solution would be consistent. The only time the system would be inconsistent is when there is no solution. So the graph, the line would be parallel, and then there would be no order pair that satisfies. So this is another way, fancy way to write the solution is empty set. This is the symbol for it. Okay, so we could have infinitely many solutions if they are the same exact line, or if they are parallel lines, it would be no solution. These are special type of cases that we have. So special cases of linear system, if both variables are eliminated, when a system of linear equations is solved, then the solution sets are determined as follows. Case number 1. There are either infinitely many solutions if the result state is true, like the example we did earlier. Case number 2, there would be no solution if the result statement is false. Does that make sense? So either if they're parallel, if two lines are parallel lines, then no point of intersection. This would be where the slope of both of these lines would be exactly the same, by the way, right? Or the second case would be infinitely many solutions when the lines are right on top of each other, just like that. The two lines would be right on top of each other. So this would be infinitely many solution, case number 1. This would be no solution, case number 2. Okay, this would be dependent, right? This would be independent. This would be inconsistent, This would be inconsistent, and there's no solution. This would be consistent. So again, get yourself familiar with those terms that we had earlier. Using slope-intercept form to determine the number of solutions. So if I have two equations here, and I want to know whether I have infinitely many solutions or no solutions, what you can do is you can write both of these equations in terms of y is equal to mx plus b. In other words, solve for y, and just take a look at the slope, because the coefficient of x would be the slope. Remember, y is equal to mx plus b. If I write standard form to y is equal to mx plus b, the coefficient of x would be my slope. So here would be the slope of the first line. This would be equation of the slope of the second line. So if the slope are the same, they're either the same line or they are a parallel line, right? So are these the same line? Looks like exactly the same line because their y-intercept is the same, right? So the lines have the same slope and the same y-intercept, meaning that they are coincide. There are infinitely many solutions there. They are dependent, right? Dependent. In this case, we have two equations and two unknown. If I solve this for y, look what happens now. The slope of the first line becomes minus 2 over 5. The slope of the second line becomes minus 2 over 5. So it means these two lines either they're the same line or they're a parallel line. But they cannot be the same line because the y-intercept is not the same. So both lines have the same slope but different y-intercept. So they are parallel line. Therefore, there's no solution. There's no solution. They're still independent, though, right? They're not dependent because there are two different lines. So they're independent, but there's no solution means inconsistent, right? There's no solution, inconsistent.